All right, let's talk about one of the most fundamental and honestly one of the most misunderstood concepts in system design, the CAP theorem. Now, this isn't just some abstract theory. If you're building apps that need to scale, and I know you are, this is something you absolutely have to get right. It's a true cornerstone of how we build things today.
So picture this. Your app is a hit. It's blowing up. More users, more traffic, which is great, right? To handle it all, you do what we all do. You scale out. You just throw more servers at the problem to distribute the load and keep things from falling over.
But there's no such thing as a free lunch. As Robert Greiner pointed out a while back, this strategy comes with a price. And that price is complexity. The moment your data starts living on more than one machine, you've opened a whole new can of worms. And that, right there, leads us straight to the CAP theorem.
Okay, so let's get our terms straight. What are we really talking about here? We're talking about a distributed system. It's basically just a bunch of separate computers, or nodes as we call them, that are all networked together and have to share data to look like one single seamless application to your user.
Now, the CAP theorem says any distributed system can only promise 2 out of 3 things. First up is the C for consistency. This is a really strong guarantee. It means that whenever anyone asks for a piece of data, they will always get the absolute most recently written version of it, or they get an error. No exceptions, no stale data, period.
Then we've got the A for availability. This one's pretty straightforward. It just means that every request you send to the system gets a response. The system is always up, it's always ready to answer. Now, that answer might not be the most up-to-the-second data, but you're going to get something back instead of just an error.
And finally, we have the P for partition tolerance. Now, partition sounds kind of technical, but it's really just a fancy way of saying the network messed up. The nodes in your system can't talk to each other anymore. So tolerance just means your system doesn't completely crash and burn when that happens. It keeps on chugging along.
So this is where the big misconception comes in. For years, people have explained this as, okay, you've got consistency, availability, and partition tolerance. Just pick your favorite 2 and you're good to go. Sounds like a pretty simple choice, doesn't it? Well, it's wrong.
And here's the reality check. This is probably the most important thing to understand about CAP in the real world. You have to assume that the network is unreliable. It's just a fact of life in distributed computing. Connections will break. Routers will fail. It's not a matter of if, but when.
So what does that mean for you? It means partition tolerance isn't on some menu for you to pick from. It's not an option. Because network failures are a stone-cold certainty, your system has to be able to handle them. It's a requirement. You simply don't get to choose.
And that insight, it changes everything, right? The question is no longer, which 2 of the 3 do I pick? Since you must have P, the real decision, the one you as the developer have to make, is what gives when a partition happens. Do you give up consistency or do you give up availability?
Okay, to make this totally crystal clear, let's walk through a classic banking example. Let's say we have a user, and their bank balance is $100. For reliability, we're storing that same balance on 2 different servers, server 1 and server 2. And then, of course, the inevitable happens. The network link between those 2 servers goes down. Boom, we're in a partition state. They're totally isolated. They have no way of syncing up with each other. Now, right in the middle of this network mess, a user's app connects to server 1 to make a $10 withdrawal. So that's a write request, right? Update the balance to $90. Server 1 does it, no problem. But remember, it has absolutely no way to tell server 2 that this just happened. And here is the million-dollar question. What should server 2 do when, a moment later, another request comes in, maybe from the user's mobile app, asking for the balance? All server 2 knows is the old value, $100. It's completely in the dark about that withdrawal. What does it do? And this right here, this is the fork in the road. This is the CAP theorem in action. You've got 2 paths. Path 1, you choose availability. Server 2 just responds with the data it has, this stale $100. Your system is up and running, it's available, but now it's inconsistent. Path 2, you choose consistency. Server 2 knows it can't check with server 1, so to avoid spreading bad information, it just gives up and returns an error. The data remains consistent, but now that part of your application is unavailable.
So which way do you go? Well, it all comes down to what you're building. It's a business decision. If you're designing a banking system, you have to choose consistency. You absolutely cannot have someone seeing the wrong balance. But if you're building, say, a social media feed or a shopping cart, showing data that's a few seconds out of date is probably fine. For those, you choose availability, to make sure the user always gets a fast response.
And I really want to drive this point home. This is not some academic debate. This choice you make between consistency and availability during a partition is absolutely crucial. If you don't think about this and make a deliberate decision from day one, you could be setting your application up for a massive failure down the road.
So that's what it all boils down to. As you're designing your next system, this is the big question you have to answer for yourself. Network partitions are going to happen. And when they do, what's more important for your application, correctness or uptime? The CAP theorem doesn't give you the answer. It just forces you to face the question. And making that choice, that conscious trade-off, well, that's what great system design is all about.